Grabbing CK proofs made in Noir and verifying them on-chain using Stylus is now possible. The entire WakeUp team has been working hard to achieve this goal. That's why we created a site with thorough documentation so that developers familiar with the topic can use our tool to accomplish this. In addition to the documentation, there are two examples. The example I'm going to show is how to build a voting app using this stack. Without further ado, let's get to the demo. The first thing we're going to do, just like when accessing any dApp, is connect our wallet. The next step is to sign a message. This will check if our wallet has an associated CK address. This CK address is not the same as a regular address since it has certain permissions that allow working with circuits and on-chain verification proofs. If there isn't one associated, the platform itself prompts us to create one very quickly. To continue with the process, we're going to create a new proposal. The proposal will be standard, just like in any voting and governance dApp. The only difference this proposal has compared to regular proposals is that it will have an input where we define which CK addresses are allowed to vote. We have set it up so that the input is entered manually, but there could easily be a different whitelist mechanism to add many users at once. Once the addresses are defined and we publish the proposal, it will generate a Merkle tree in the background. That Merkle tree is what will later allow us to verify whether or not we are eligible to vote. Note that the wallet we're using to vote is the private wallet. However, the wallet that created the proposal is the public wallet. Here, we are trying to vote in favor. What we're doing is paying the gas for the transaction and making it demonstrable that we are the owners of the CK address that has the right to vote. Another important detail is that this verification proof does not allow us to vote twice. Having seen this example from the UI, now let's look at the same example from the CLI. All the documentation you're seeing on screen is also available on our public GitHub. Let's go ahead and replicate the flow we did earlier. The first thing we're going to do is generate our CK account. We can see the different addresses it generates for us from our private key. The second thing we'll do is precisely to submit the proposal. We've already prepared a JSON with its description and in addition with the whitelisted addresses that have permission to vote. Remember, those addresses are CK addresses. The next task is precisely to generate that proposal on-chain. And as we explained in the UI video, what it will do is generate a Merkle tree, create the proposal on-chain and assign it an ID. What we're going to do now is run a simple command to check if that proposal has indeed been created. As we can see, it is created and for now it doesn't have any votes. The next step is to vote. In this case, we're going to vote for option 1, which is to vote in favor. What happens here is that it retrieves our CK account, checks if it is eligible to vote and then actually casts the vote. Once the vote is cast, a stamp is left on chain. Finally, to see if the vote was properly cast or not, we're going to check the proposal again to see if anything has changed. As we can see here, now there is one vote in favor and none against. Even though this mechanism seems very simple, what is actually being tested is not. If this is a tool you'd like to implement in your project or you're developing similar solutions, don't hesitate to send us a message. We'd love to give you a hand and collaborate. We hope you enjoyed the demo and that it sparked your curiosity. See you in the next video.